Okay, in this video, we're going to look at how to calculate using formulas in Excel, not the built-in formulas, but constructing our own, trying to solve formulas that maybe were given in a course. Now, we're going to look at a couple of examples. 3 of our examples are going to be statistics formulas. Some of them are simpler than others. And then we're also going to look at 2 examples from algebra. The final example is quite complex. And so we'll use some of the tricks that we can use to sort of help with setting up our formula, doing things in stages rather than sort of getting bogged down in lots of embedded parentheses like we have to do in our calculator. All right, so our first example is an example from algebra. It's simply a quadratic equation. We want to find the value of y given some input values. Now, a really good way to use formulas in Excel is to use the cell values as they are constructed for us to build our formula. And so we can update the values very easily. Once we've built our formula once, we never have to do it again. So let's say I want to solve the equation. I want to find the value of y for y equals 2x squared minus 11x plus 8. Okay, so what I'm going to do is I'm going to configure first my a, b's, and c's. So those are the coefficients in my equation. So a is 2. The sign goes with the number. So this is negative 11. And then the constant is the c value, that's 8. Now, if I want to evaluate this at a particular point, let's say x equals 3, then if I'm doing this by hand, I have to be very careful about making sure I'm squaring and things like that. But in this case, again, I'm just going to specify my x value here. Where the difficulty comes in is where now I have to set up my formula to do this calculation with my formula. So I'm calculating, so I start with an equal sign. I need 2. I have to, in Excel, explicitly specify any multiplication that I'm doing. My x value, I don't want to type it in because I want to be able to update this quickly. So my x value is in this cell, D2, and I'm going to square it. And then I'm going to add, and again, I don't have to worry about the sign in this general formula. The sign is already here, times my x value again, and then plus my constant. And then if I hit enter, it's going to calculate all of that information. Now, why is this super useful? Because if I want to change my x value, let's say instead of doing 3, I wanted to do negative 3. I can just type it in here and the number will automatically update. Now, this is really useful because I know I myself was very good at losing minus signs when I did arithmetic. And I honestly didn't get better at it until grad school. It was a notorious problem. And remembering when you square a negative that it becomes positive, and remembering to multiply the negative by this negative and making that positive, it's easy to forget, especially if you're trying to do things very quickly. You don't have to worry about it in Excel. Once you set up your formula, then you just put in your new number and the formula will automatically update. And moreover, if you have another equation that you want to solve, then all you have to do is change the coefficients that go into it, and you can copy and paste your formula and it will automatically recalculate. So now let's say if I wanted to do 3x squared plus 2x minus 1, and I wanted to evaluate it at x equals 4, well, because I'm using these cell references and not putting in individual values, I can just copy this formula down to the next line, and it will follow this same pattern, this general ax squared plus bx plus c, and it will substitute x equals 4 and all of these coefficients into my formula. All right, so our next couple of examples are statistics examples, and they're not quite as involved. But we do have to pay attention, particularly in this first example, to our parentheses. Now, this is the standard score formula that shows up all the time in statistics. And the X is our observation value. Mu is the mean of our distribution. Sigma in the denominator is the standard deviation of our population. Basically, this is going to tell us how many multiples of the standard deviation is my value away from the mean. So let's think about like an SAT test. Typically, an SAT test has a mean of 500 and a standard deviation of 100. And let's say that you get a score of, I don't know, I had a friend once that got a 205. And so when we calculate this, we're going to calculate it using cell references so that, again, we can update the cell values and then it will recalculate. So now the one thing we have to be careful of here is we don't want sigma to only divide mu. We need sigma to divide the difference between X and mu. So we put a parentheses around our numerator first, and then we can divide by our sigma. And so negative 2.95 is not very good. Negatives mean that you're below the average. And again, if I want to, I can copy this formula down and then I can replace my value. So maybe that friend had a very bad day, but let's say I had another friend who did a slightly better job. And let's say they got 610. You change this one value and it will automatically update the whole formula. And indeed, if you wanted to, you could change all of the values. Let's say we wanted to do an SAT where somebody got, or sorry, an ACT test, which is on a completely different scale. They scored a 27, but the mean is 21 and the standard deviation is 5. And again, the advantage here is that it will automatically update these calculations just because you're using the cell references. The standard error formula, again, is very common. S, or again, it's sigma, depending on whether it's a population or a sample standard deviation, but the formula works the same in both cases. N is our sample size. So let's say I have my SAT has a standard deviation of 100. I'm taking a sample of, let's say, 45 students. What is the standard error? This is a nice simple formula, but it does involve the square root of the sample size. If you don't know what you need, like what the letters are for a square root, you can always search for it by going up here to the insert function and then typing in a verbal description of the function you're looking for. And it will give you a list of things that have those keywords in it. And then you should be able usually to track down which formula you're looking for. Now, the formula for the proportion standard error is a little more complicated. Everything is under the square root. So let's say we have a proportion of, let's say, 46%, and we took a sample size of 700. Sample sizes in proportion problems are usually always much larger than sample sizes in problems involving means. Our standard error starts with the square root, and we need to be careful about how we put in these parentheses. These are multiplying, so they're not adding or subtracting, so we don't need an extra set of parentheses, but we do need to specify the multiplication. That's already in parentheses, and then divide by our sample size. And again, we could represent this as a percent. The standard error should often end up being in the sort of small, but up to 5% range. Again, smaller sample sizes, bigger standard errors. And then the final example that I wanted us to look at is something much more complicated, and that is the quadratic formula. So let's say I had this formula up here and I wanted to find out where it was equal to 0, not just evaluate it at a particular value of X. I want to find out where exactly it's equal to 0. Then I need to use this formula. So in that circumstance, let's use these values again, 2, -11, and 8. Now, this formula is very complicated. In fact, it has 2 roots. So there's actually the plus and minus sign means that we're going to have to do it one time with the plus sign and one time with the minus sign. And so I've set it up root 1 and root 2 to do that. But in order to get there, we have to first figure out this thing under the square root. And then we have this thing going on in the denominator. And again, if we were to try to do this all in one formula, we would need several embedded parentheses, and then we would need another embedded parentheses in the denominator, and then we would need to do 2 versions of the exact same thing, the whole shebang, in order to change the plus and the minus sign. But what I'm proposing here is that you can use Excel to do intermediate calculations so that you don't have to work quite as hard when you actually go to calculate the individual roots. So what I'm going to do here is I'm going to first calculate the value under the square root, which is a much simpler formula. It is b squared minus 4 times a times c. And then 2a, that's my whole denominator. So that's 2 times, again, I'm not filling in the value for a, I'm only filling in values like the 4 and the 2 that are constant, and then using cell references to do that calculation. And then all I have to do is for root 1 minus b plus the square root of 57 divided by 4. I haven't broken it up enough in order to have no need for parentheses, but instead of having lots of embedded parentheses, I can sort of manage the number of parentheses that I have to worry about. And again, you can break this up into further pieces. You could have a column where you specifically calculated the square root, and then another column where you specifically calculated the numerator for the plus version, and then did the division afterwards. So you can break this up more if the parentheses in particular are getting you down and they're giving you bad answers all the time. The further you break this up, then the fewer parentheses that you will have to worry about. You can let Excel show you the calculations all along the way, but then you still get the right answer. And then here, I'm actually going to copy the text of this formula and then just change the sign. And so these are my 2 solutions. If I were to make a graph of my quadratic equation, then my intersections, my intercepts, I would have one just a little bit smaller than 1, and I would have one that was a little bit bigger than 4. And as I'm going through these calculations, if I find that my term under the square root turns out to be negative, then I know that these answers are not going to be real. In other words, there's no solution. And once I have these formulas set up, of course, now I can change my equation. Maybe up here, we looked at this equation, 3x squared plus 2x minus 1. These are the roots for that particular equation.